Let's take a look at another graphing a cube root problem here. Notice that this one is the cube root of x minus 5. Remember our basic formula, y equals a root of x minus h plus k. What these things tell me is whether it's a square root or a cube root, a determines how wide or how skinny the graph is, right? If this was the cube root of x, it would look like something like that. If a was greater than 1, it'd be really wide like this. If a was less than 1, it'd be really skinny like this. Okay, so let's not forget what that means, but a is 1 in this one. Oops. A is 1 in this one, so it's not going to affect the graph of that at all. Plus k, there's no k out here, so k is 0. It's not going to shift up or down at all from the normal shape that comes with a cube root. Okay. The h, however, they're looking for a minus here, and this is a minus 5. That means it's going to shift over 5 times. Notice my grid here is every 2 boxes is 1, because there's 2, 3, 4. So right here is going to be what I call the vertex of this, or the place where it crosses the x-axis. Okay, y equals cube root of x would cross right in the middle and be something like this. Okay, but this one's going to be shifted over 5. That's what this tells us. This moves it over 5, so it goes right there. All right, now the next thing I want to point out is that we can find some other values just like we would if this was y equals cube root of x, but let's pick some smart values here. Okay, if I know that it's going to go right through this point here, why don't I pick points on either side of that? So if it goes through 5, 0, then let's figure out another point that goes on there. Okay, let's try, how do I get a 4 under the, how do I get a point on either side of that 5? Well, let's try 4. Okay, see why I'm trying that? I want to try a point on this side and a point on this side. I'm going to try 4 and 6. Okay, when I plug in a 4, I get 4 minus 5, that's minus 1. Cube root of minus 1 is, well, minus 1, because minus 1 times minus 1 times minus 1 is a minus 1. That's the definition of a cube. Okay, if I put a 6 under there, so first of all, 4 minus 1. Minus 1 is actually here. Okay, so there's 2, there's minus 2, there's minus 1. Okay, so this is going to be right here. At 6, I get 6 minus 5 is 1. Cube root of 1 is 1. So at 6, I'll get 1. It's going to be right up here. Okay, and where else can I go? I know 8 is a perfect cube. How would I get 8 under there, or negative 8? If x was minus 3, okay, I'd get minus 3 minus 5. See why I chose minus 3? It's minus 8. Cube root of minus 8 is minus 2. Okay, so at minus 3, way out here, the graph is actually minus 2, which is here. So now I'm getting a feel for this curve. Okay, maybe it helps to have it in a different color. Okay, origin is here. 1 point is here. 1 point is there. Now this one is way out here. Where it hits positive 2 would be way out here. If I were to plug in a 13 for x, okay, 13 minus 5 would be 8. Cube root of 8 is 2. So it's not going to hit 2 till I get way off the graph. There's 10. There's 11. If that's right. Is that 8? That's 8. So that's 9, 10, 11, 12, 13. It wouldn't hit 2 till way out here, way off the graph. Okay, but I do get a feel for this curve. It's going to look something like this. And I didn't draw that last part very well. Okay, it'd be something like this. Not go up to 2 until it gets way out here. Okay, so there's what your graph looks like. Now, these types of questions often ask, what's the domain and the range? Well, think about the domain. Is there any x that is there any value for x where it would give you something here that is not a function? If this is a even root here, then you have to watch out for negatives under the radical. But with cube roots, you can have a negative under the radical. We just showed that. 4 minus 5 is minus 1. The cube root of minus 1 is minus 1. So there's no limit to the x's we can have. So for domain, that's which x's will actually make the function work. It's all real numbers. Okay, this is my way of writing numbers. Okay, for y, even though x is going to go side to side greater than y is, there's no limit to y. This will keep going, although slowly, towards negative infinity. As x goes towards negative infinity, this graph, the y value, will also get bigger and bigger, although it'll get there slowly. So keep in mind that the range is the range of all y values. Okay, is there any y value you couldn't get? No, so this is all real numbers as well. Okay, it's with the even ones, or where you're going to get, say, an x in the bottom where you have a problem. Like if this is 3x over x minus 1. When x is 1, you get a denominator of 0. That's undefined, so you couldn't have a 1 as part of your domain here. Don't worry about this for my function here. This one is all real numbers are eligible to be x. There's no x values that would make this not a function. And as far as the range, this is all the y values that would come out of this. So you can have any y value, you can have any x value. I hope that much is clear to you.